Well, hi everyone, welcome to another video. This one is all about logarithms. So if you're watching it, you hopefully have already done your index laws, you've already done graphs of exponentials, and as part of that, you looked at a video that talked about graphing logarithms. So you know a little bit about logarithms already. You've also hopefully done a bunch of solving of equations and watched that video, and hopefully you've already done quiz 1, which would have been on Desmos. So if you have not done those, stop this video and go do those things. Alright, this video is intended to cover both lessons 4 and 5. It'll talk about what logarithms are and get you used to using them, and then it will also mention how to actually solve equations using logarithms, and particularly we're going to look at some log laws as well. So it's a 2-lesson-in-1 video. Well, let's just get stuck straight into it. So logarithms, what are they? Well, they are the opposite of exponentials. And you've probably already seen me write something like, if you have 2 to the power 3, that's 8. And that is the equivalent thing of writing logarithm with a base of 2, since the base is 2, of the answer 8 equals 3. Same piece of information presented in 2 different ways. So we could say from this that you notice that logarithms are opposites. You also know from the previous video, the graphing video, that another way of thinking about logarithms is that they are inverse functions. So 2 inverse functions would be the function of, say, 2 to the power of x, and its inverse function is logarithm with the base 2 of x. That's what you get if you swap x and y, doing the inverse thing. Now there's a third way of thinking about what logarithms are, and this third way is my favorite way actually. Logarithms undo exponentials. Now this is a little bit more of a technical way of thinking about it, but it's much more versatile. It essentially says that if you have the equation, let's do one that we've seen many times before, 2 to the power 3 equals 8. Well, if you want to undo this, you can apply a logarithm to both sides. So what I'm doing to both sides is I'm going to be doing a logarithm with the base 2 to both sides. And what you get is, of course, logarithm with a base 2 of 2 to the power 3 equals logarithm with a base 2 of 8. Now, what I mean by undo is that the logarithm cancels with the base. So they undo each other, giving you just 3 on the left-hand side equals log base 2 of 8. And this is in fact the best way of thinking about logarithms. Let's do a few others. So suppose you have 5 to the power x equals some random number, 14, and you want to solve this. Well, what you do is you undo the power of 5 bit by doing a logarithm, and you then get just x, and you get logarithm base 5 of 14. Because what you've secretly done there is the log base 5 to both sides. The power of this is that it also works the other way. If you start with, say, a log base 10 of something random, 26 equals some number, let's call it y, then you could re-represent this in different ways as well. You need to think, well, what's the opposite of a log? Well, that's a power. So what you have to do here is, instead of a logarithm to both sides, 10 to the power of both sides. 10 to the power of. And that undoes, the 10 to the power undoes the log, giving you just 26, and that'll equal 10 to the power of y. So that's how these logarithms really work. You can do this a more common way, like if you have log to the power 6 of x equals 36, for example. A way I could do this is 6 to the power of both sides, and you can see what's happening here. The 6 to the power of log base 6 cancels out, leaving you just with x, and here you have 6 to the power 36, a truly gigantic number. And By doing this way, the undoing method, it means you don't get confused. Because in this last example, too many people would go, oh, I see I've got a log base 6 and I've got a 36, so surely x is 2. Because what people might be thinking is 6 squared is 36. And that would be an easy mistake to make, but it's not written in that way. And the easiest way to not make that mistake, of course, is do the undoing method. So there's 3 different ways of thinking about our logarithms, and the undoing is the best one, the best way of thinking about it for equations. Okay, there are 2 really key log properties that we need to know of. The first one is any log of any base of 1 is always 0. That's just because we already know the index law fact that any base to the power 0 always equals 1. So that makes a lot of sense. This one's it's particularly important when you think about this to remember the basic log graph. Vertical asymptote goes this way and its x-intercept 0, 1. Oh, whoops, I've written that backwards. Sorry about that. 1, 0. So you can see that's kind of the standard x-intercept, and that comes from this property. That's what that's really talking about. The next property is the property that comes from the fact that if you have any base to the power of 1, you get itself. And that's what this is saying. Log base a of itself is 1. So 2 very important log properties. We also have 3 log laws. Here they are. The first one basically says if you have, or for all of these log laws, you need the same base. So notice the base a each time. The first one says that if you have 2 logarithms with the same base added together, you can multiply the bit in brackets. By the way, the bit in brackets gets a fancy name called argument, which you don't need to know, but sometimes I'll refer to the word argument in my videos. It means the stuff inside the brackets. So it's kind of saying if you have the argument m and n will kind of combine, multiply together to be the overall argument here. Log law 2 is basically the same, but with subtraction and division. And the third one, by the way, notice how these 2 log laws, the first 2 log laws, are kind of like the opposite. They're kind of like the opposite of the first 2 index laws. And that makes sense because logarithms are basically the opposite of powers. Okay, this third one here, notice if you have some sort of coefficient out the front, it can jump up here to become a power inside the argument. So we need to understand those 3 log laws. We need to have them in memory very well. And so just to kind of give a really quick way of thinking about them, let's just do a couple. So imagine you have log base 2 of 6 plus log base 2 of 3. Well, you'd use log law number 1, and that becomes log base 2 of 3 times 6 is 18. Or you could use the second log law. Imagine you have log base 2 of 6 again, plus, this time minus log base 2 of 3. Well, this time we do the division. 6 divided by 3 is 2. And using our property, log law property, we've got the same base as our result, and so the answer is in fact 1. A quick example of log law 3, imagine you've got 5 log 2 of I regret doing 5, let's just make that a 3. 3 log 2 of 3, well that's the same as log 2 of 3, and this 3 becomes a power, 3 to the power 3, and that's the same as log base 2 of 3 cubed, 27. Something to look out for, of course, is the third log law presented in a different way. Like for instance, you might have a log base 2 of 8. Well, one way of doing this is changing it to log base 2, and 8 is in fact 2 cubed. Then going backwards with log law 3, the 3 can come out the front there, giving you 3 log 2 of 2. We know log 2 of 2 is just 1 using that second property, and so this all equals 3 times 1, which is 3. So keep that both ways of thinking about the third log law in mind, forwards and backwards. All right, that's really just the intro over. We're now going to do 3 examples, which hopefully will show you how these log laws really apply. So let's get into it. Well, here I notice I've got the same base each time. I've got an addition between these ones and then a subtraction. So I'm going to be using log laws 1 and 2. But before I start, I realize I actually can't use those laws yet because this one has a coefficient of 2. So before I can use log law 1 and 2, I have to get rid of that 2 there. So the first thing I'll do is change this to be a 5 to a power of 2. So that'll be 5 to the power of 2. These two parts, I actually, it doesn't matter which order I do the plusing or minusing in, so I might as well do this bit now, which is log 10, 120 divided by 3. Now I notice, of course, that 5 squared is 25, and that 120 divided by 3 is 40. Now I can use log law number 1, do 25 times 40. And, well, 25 times 4 is 100, so this must be 1000. Now this is kind of saying we've got a base of 10, what power gives us 1000? And so you can see the answer must be 3. All right, moving on, example 2. Well, here, firstly, I notice that I'm trying to solve an equation this time, not just simplify. There's actually a few different ways I could approach this. So let's just start with perhaps the easiest, which is I'll subtract this logarithm from the right over onto the left. So I'm going to do log base 3, 3x, subtract log base 3 of x minus 2 equals 2. Because now I've got all the logs on one side, and I notice the logs have the same base of 3. So I can apply index law number 2, which says we can do a division. Okay, here what I want to do is undo the log. So what I'm going to do is 3 to the power of both sides. 3 to the power of both sides. And if I do 3 to the power of the left-hand side, it cancels with the log, leaving me just with the 3x divided by x minus 2. 3 to the power of 2 is 3 squared, which is 9. Next, I'll multiply both sides by x minus 2. Because I don't like fractions very much. So here we've got a 9x minus 18. Well, this is a simple equation. We've got 18 equals 6x, and you can see that x is therefore 3 in that particular example. Wonderful. Okay, last example that we're going to do in this video. We're going to, it's another solve one, just like before, very similar. So what I want to do is ask you, please pause this video right here. There's the question right there. I'm not going to do this one right now live, but I want you to have an attempt of it, and then check out our OneNote as the solution will appear in our OneNote video. All right, thanks very much for being there, and I look forward to seeing you in our next live lesson.